Chiara Latessa. I'm a tenure track position at the Department of Physics at the University of Trento in Italy. And today, at the annual Radiation Research Society meeting, I'm interviewing Dr. Thomas Berger. Can you introduce yourself first?
Yes, I'm a physicist. I'm the head of the biophysics group in the Institute of Aerospace Medicine, the German Aerospace Center, where we deal mostly with radiation exposure, influence of radiation on humans. And so my background is physics.
Okay, and I know that this is your first Radiation Research Society meeting. So how has it been so far?
Well, I've been, first of all, very honored to be here. It's a perfect place. Very nice talks. I really try to manage to be there every day at 8 o'clock for the refresher courses, which I liked a lot, especially if you're a physicist and you have a physics background, to get a little bit more background in medicine and biology concerning radiation. That's, I think, very important. So it's always, you go to conferences, you always learn something new.
So compared to the conferences you usually go to, how is this conference similar or how is it different?
Well, if I compare it to the big conferences, like the big space conferences, like COSPAR, where we normally go every 2 years, it's of course different since it is focused on radiation and more like the medical part of radiation. So you see a lot of cancer therapy coming in, which is on the other hand also quite nice, because cancer therapy and space radiation, they have a lot in common, especially with all the upcoming proton and carbon therapy facility centers. So there is always a very good connection between Earth-based application of radiation and space-based application. So that's why I also like this conference.
Okay, and maybe just so that people know what you are doing, maybe if you can tell a bit more on specifically on your research. So that
well, the research we are doing in our institute is mostly focused on radiation protection of the astronauts. So we are developing radiation detectors for the International Space Station. We are responsible for providing personal radiation detectors to the European astronauts. So this is kind of a contract we're doing for ESA to prepare also the relevant medical reports after their exposure. We're developing new detectors for the International Space Station, but also for future lunar missions, and we're also participating in the MSL-RAD instrument, which measures the radiation at the surface of Mars, already since 5 years.
And it's probably easily to the next question. So what about Mars? How far are we from Mars? That's my personal curiosity.
Well,
I know, but
it's a good question. I was just at a conference last week in Las Cruces, New Mexico, where it's an international conference about future personal and private access to space in cooperation with NASA, but also all the private companies which come up. I would say everybody wants to go to Mars, definitely. Currently the next phase will be going to the moon, that's for sure. I mean, NASA and the Europeans are working on the so-called Deep Space Gateway, which is a cislunar station which will circle around the moon and which will enable astronauts to travel there and stay there, prepare for Mars missions. So that's, in principle, you could say going to moon is the next precursor step for going to Mars. So you go to moon, you test all your technical, whatever kind of thing you are developing, and then try to prove that it will really work. I mean, the advantage is if you're at moon, you can go back to Earth in 3 days. So, but then if you really say you want to go to Mars, you have to be really sure that you cope with all the technical issues and you are ready to go there, because if you put a start button, then you come back 1,000 days later. So you have to be sure that everything works out fine.
How did you get into this field?
Studied physics in Vienna, Technical University, and then the colleagues, there was an Austrian astronaut flying on the Russian Mir space station. So my professor had good connections with the colleagues in Russia, and they were working on an experiment where they used a water-filled phantom to simulate a human torso on board the Mir space station. So to measure radiation inside the phantom, which is equivalent to the radiation inside a human. So you can say skin dose, organ dose, etc. and I was searching for a PhD thesis, and then my professor said, well, there is this experiment with the Russians, you want to do it, and that brought me into space, or at least to the Mir space station at this time.
Okay. So, and let's say if you would have to advise, or I'm sure in your group there are younger students, you would have to advise on what to do and if to be into this field, what would you say?
Do it. It's cool. I mean, space research by itself, it's cool. There are not that many people doing it. Space radiation research is even cooler, because, I mean, it's the physics you do, but then you have to work together with the medical doctors, with the biologists, to get the humans, first of all, up there, and then really safe back home, and also work on all the radiation-related topics like risk assessment and detector development and Monte Carlo simulation. So it's a quite wide field, and it's very interdisciplinary, and I think that's what it makes so interesting to work in.
And if you compare this conference to other conferences you go to, do you see that, for example, the participation of younger scientists, early career investigator is higher, lower, could be improved?
Well, I see a lot of young scientists here, I have to say. Well, younger than me for sure, but definitely a lot of students. So I think that.
But if there is something that you would change in this, being your first conference, like, you know, as a completely fresh pair of eyes, what would you change or would you improve? If there is anything, maybe it's perfect.
No, I think I like it. I mean, I would have to go to the next one to see what changes from this one. But I think all the way how it is built up with all these refresher courses, the interdisciplinary lectures, etc., and it's a quite broad field. I like it a lot.
Okay. Do you think there is a bit of physics missing here, or would you, as a physicist?
Yes, of course. A physicist would always say this. I mean, there were certain sessions which were related to physics, either space radiation or also epidemiological. Okay, this is always a word I got totally wrong in English. Epidemiological studies. There was some physics there. I can of course understand that the medical doctors, they want to discuss like cancer therapy, etc. But of course, there is a lot of things going on in physics in terms of modeling, like track structure theory, etc. So really model the first incident of radiation and the interaction with the DNA, chromosome operations, etc. So I would say it always helps when you bring people from diverse backgrounds together, because the physicists tell you this, and then the medical doctors say, yeah, but I don't understand it, explain it to me. How can we use this really for applications which really have to do now? So I think I would have nothing against having more physics here.
So, and a question that is kind of interest for me first, but hopefully for everybody else who's listening. Being more in contact with the ESA, I mean, being in Europe, how do you see, for example, the programs? How compare ESA program compared to NASA? Could you talk more? They go in similar direction. I'm curious. No, I mean, you don't have to answer to. No, I don't want any political, any political incorrect.
The problem is I can only answer with a political statement, which I refrain to do. Well, I mean, you have to say ESA is a big part of the International Space Station. So they have the European Columbus Laboratory up there. There's a lot of barter agreements going on between ESA and NASA in terms of human presence in space, like also agreements with the Italian Space Agency, for example. That's why we now have an Italian astronaut up there on board the space station. So in this sense, if you ask in terms of cooperation, there's a lot of international cooperation going on between ESA and NASA in terms of human spaceflight, and that also applies to the future directions when we think about the deep space gateway, etc. Now I'm just talking about space. I mean, this is something also with the Russians, this is something which can only be done in international collaboration. If you talk to the colleagues from SpaceX or Orbital, which are doing private flights to the space station, everybody will tell you for exploration mission, this is something where everybody has to work together, because it's such a big amount of effort to go for space. In terms of science, I would say also here, like for radiation detector development, Monte Carlo simulations, doing science together, there's a lot of interaction between European member states or ESA member states and NASA, and we're all doing experiments together on board the ISS. We're all comparing the results of what we are doing, which is actually good, so we are talking to each other. In terms of biology, or let's say radiation research, there is an ESA roadmap for what ESA wants to know in the next 10, 15, 20 years in terms of question to be answered for biology, so it means radiation and biology, and also radiation and physics. So radiation and physics, for example, I mean, that's very similar to the NASA roadmaps. You have to be able to model the radiation environment, you have to be able to provide active radiation detectors personal to the astronauts. You have to be able to predict the environment in which you're working on. It's very similar goals. And also for the biology, there's just a new ESA program, the ESA IBA program, which just came out to use accelerator facilities in Europe for answering kind of baseline questions for radiation biology, dose rate effects, possible CNS effects for long duration space missions. Of course, in the US, you can be happy. You have NSRL, you have a dedicated facility for space radiation research. But then you can say also Europe has dedicated accelerators which they can use in principle as kind of dedicated facilities. So I think we're on a good way.
They even out. So, last question, maybe before you go. Can you think of a point in your career where you moved from being more like a student to become more an early career investigator, or like, you know, where you made the jump from say, okay, I made it? That's maybe what many young people hear.
Well, as a student or as a PhD student, the nice thing of being a PhD student is that you can really work and focus on something for a few years. So you don't have to care about anything else. I mean, you got to work and you focus on it, and that's cool. And that's something you will never do in your whole life again. So as soon as you start as a postdoc, bureaucracy kicks in, and then when you go on and you start like being, you have to do project management, etc. The older you get, the more bureaucracy kicks in. The real changing goal was when, or changing moment, when I had my first experiment on board the space station, where I was the principal investigator. So then it's like you're the PI, it's your experiment, and that's cool. Yeah. Even if it does not mean anything, but it's really cool. I mean, you build something, you send it up, it's doing something good, and then data comes down, etc. And that was really like when I say, okay, I think all the way which ended up at this point was not that bad.
Okay, so with that, I want to thank Thomas for dedicating us some time to talk to us, and we hope to see him next year, that we were good enough to interest him to come back.